bar. Can I see? Can you see that? I'm moving the menu bar. Can you see that? Compute and math. Can you see that? So you will find all of the available operations here. ADD, what is this? Addition, okay? Subtraction, multiplication, division, square root, blah blah. The TOD, FRD. TOD, FRD is the conversion between the binary number and the decimal number. Binary number is 0, 1, 1, 0. Decimal number is what we 1, 2, 3, 4, 5. Okay. So let's find this out. The first one is, it's called a move, MOV, move, to move the data. Many of you will study digital electronics this semester. In digital electronics, we will explain to you an important digital system. It's called shift register. Shift register. When you do the calculation, for example here, you enter 2, then the plus sign, right? 2 plus 3, what else? What's next? Equal sign, right? Equal. It show you 5, do it, right? 2 plus 3, 5. How does it make it? You enter the information. The information, each key is converted to a post string 0101, 11100, okay? But they need to move, like the parts move on a conveyor belt. What is a conveyor belt in the chip? Shift register. Shift register. It moves the data, moves the information. So, the move, where is move? Can you see that? Move, logic, okay? We will study logical instruction later. So MOV, move, shift register. This is shift register. You can get it here, from here. Let me, in this instruction, I'm going to move from source, a number 6, to the address, to the destination address. Okay, what is the address? N7. What is N? You see this, the data file. Okay, it tells us everything here. This space in the chip is the memory. Okay, so under the microscope, if you see a chip, then under the microscope, you will find it's like a real estate in New York City. This is a factory, this is a park, this is a restaurant, these are the commercial zone. What can I say? In the chip, there will be a space dedicated to memory. Okay. So for example here, memory. This space, in this space, all of the information is divided into different types. Okay, for example, what is this type? Input, they are from sensors. Output, they are going to the motors, air cylinders. What is this? Binary, right? Timers, counters. N7, integer. Integer. So probably it is here. Integer. All of the integer are saved here. Okay. It will be why? It's the same. It's like our human brain. According to anatomy, the music is here. Mathematics is here. Sports here. Make sense? Why? Because it's efficient. When you want to read or write information, you don't have to go randomly. Okay? If it's integer, make sense? Okay? And it's like I wish you still remember the structure of the memory. So it's like a hotel. for 500, there are 16 bits. 16 bits. Oh, come on. This is the first floor. Okay. If this is a hotel for the integer, this is N70 for the first floor. Can we understand it? N71, the second floor. Can we get it? Okay. How many rooms are there in energy storage? 16 single rooms, right? 16 units. So in each unit, so the address of this unit is what? N700. Make sense? The address of this room is N701/1. Okay. In each room, there are two possible states, 0 or 1. So each room can control a motor, digital, either on or off. Make sense? Either 0 or 1. But if you want to control the velocity of the motor, the velocity is a real number. So it can be, say, 000111010, something like this. It's a binary number. You use the instruction, then you can convert it to decimal number. 1800 RPMs. All of us, we are humans, we can understand. We cannot understand this. 0110, what is it? We don't know. We need to convert it. Can we understand? Okay. So if we use all of the 16, it's called a word. It's called a word. A word is the unit for the memory. Okay. This is called a bit, and this is a word. 16-bit word. 8 bits, 1 byte. Okay. So here, the address, the destination address is N70. So let me do it. I pull the trigger. So let me turn on this box. See? So can we see that? Currently N700 is what? 0. So if I hit the switch, can you see that? It becomes 6. Why? Shift register. 6 is entered to the destination address. Can we get it? Okay. So what if I do this? Then another number from the number in 70 is 6. 6 will be added to 2, and the result, the sum will be stored in a new address, N71. 6 plus 2, 8, which is stored here. Any question? Next, subtraction. 6 minus 2. The difference will be stored in N72. 4. Can we understand it? Very straightforward, all right? Multiplication. Okay. 6 times 2, 12. 6 divided by 2, 3. Division, this is division. TOD, and FRD is to convert between the binary and the decimal. Okay. For example, okay, the radix, if I change the radix from decimal to binary, you can see better. So TOD, so the source, in the source, the number is 675. I want to convert 6 to binary. Do you know how much is it? N70 is 0, no way. 6. Oh, there's a, well, whatever. Forget about it. So I made a mistake here, down here. So if I hit this switch, it should be 6. How much is 6? 1? I forget. So there will be one. It will be a binary number equivalent to 6 downloaded. FRG is a reverse operation. So next, I want to show you copy. Copy is tricky and dangerous. Copy, okay? Why I say it's dangerous, I want you to be aware of it. Otherwise, you will be held accountable because you may lose money. Copy paste, okay? So N7, this is N70, N7172. Okay. I just take it for example. For example, the information is 1, 2, 3. 3 numbers, 1, 2, 3. I'm going to copy paste to the destination N78. Oh, there's also an important point. Can you see the pound sign here? The pound sign. It means, if you see the pound sign, it means it's a multiple address. Okay? N70 is the starting address. N78 is the starting address. How many addresses, how many units are there? 3. See the length is 3. So N70, if it is the starting address, there's 3 layers. So 2, 1, 8, 9, 1. I want to copy the information from here, starting to the destination. So it will be after it is executed. Can you understand that? Usually at the beginning of each process, you want to copy paste the number of, for example, your recipe. You make bread, you make a coffee cake. The recipe, the ingredients, you copy it, boom, to another address. Okay, then you can make it. Right? Why did I say it's dangerous? Be careful. You copy, you'd better copy it to an address far away. Otherwise, if you do this, say starting address 70, destination 71. So you want to copy it, okay, this way. This way. Can you see that? You want to move it 1 layer up, okay? However, it didn't go your way. How does it go? How does it work? If you copy this way, okay, so first, 1 is written here, then 2 is overwritten, you lose the information. Then 2 is written to this layer, information is written to the next one. You end up with 111, you lose the information. You have to buy from your vendor again. Can you understand me? I want you to be aware of this. Okay. Next, fill and clear. Fill and clear. You will find you always, if it's a real PLC program in your factory, you always find a fill and a clear, either at the beginning or at the end of the cycle. Why? Safety. Before the process starts, you want to make sure all of the everything is 0 off. Okay? So if you fill source 0 to destination N70, so all of the 16 bits will be zeroed at one time. Makes sense? All of them. Clear. N70, all of the 16 bits will be 0. Usually, you will also find them at the end of the cycle. Everything is homed, de-energized, 0. You don't have to 0 each device, each is 0, 16, 0 a word, okay? 0 this, then, okay, or actually, use 0, N70, N71, the length is 10. Can you see that? So totally 10 layers, 10 times 16 bits will be 0 at one time. Can we get it? Okay, so in the rest of time today, I let you, okay, this is yours, you can take it. I want you to enter, okay, you can take a photo of these two programs. Enter and